Hi, hello everyone. As an architect, dividing a curve is in something new. We have done in AutoCAD, SketchUp, or whatever software we use. Then what is special about Grasshopper divide component? Grasshopper has not one component, it has multiple divide components. Let's see each component and when to use it. Let's start. Let's start with the basic one, divide curve. Let's add bifocal. So you can see the component name. Before we start, we take a look at the inputs and outputs of the component. In the inputs, curve, count, kings. Curve, we understand we have to give the curve. Count, how much we have to divide. And kings, we will see in a moment. In the output side, we have points, which will give division points, and tangents, which will give the direction at the particular points, and the parameter, which we have seen in the last video. Let's bring the curve into Grasshopper and see how this is working. Let's draw one curve. Let's connect that curve. That's all. It's automatically divided that equally. If you overlap your mouse on the count, it will show 10. So the default value is 10. Which whenever you are giving the curve, it automatically divides that curve into 10 parts. If you want to change the number, we have to use the number slider. For that, we will use, let's say, 2 division, 3, 4, 5, whatever it is, it will divide into that many segments. Always remember, the number of points will be always plus 1. There are 6 segments, 1, 2, 3, 4, 5, 6. But there are 7 points, 1, 2, 3, 4, 5, 6, 7. So whenever you are inputting the count, it is always the segments. Then there is kings. If you overlap, it is showing false. So it is a Boolean value. Let's make it true and see what happens. Boolean toggle. It's already false. True. Did you see anything changes? Let's click again. Nothing changes it. Kings will be only useful when your curve has some kind of edges. Let's draw another curve. Let's copy this. Let's connect this curve. This curve also divided into 6 segments. So when you make the kings true, it will divide the curve in the edges also. Let's connect the panel and see on the both of them. In the smooth curve, when you look at the panel, we have 7 points. It is showing 6 because it will start from the 0. Counting 0, it will totally 7 points. At the same time, if you are looking at this one, you can see 10 points because this is true. When you switch into false, it will become 7 points including 0. If this is clear to you, let's move to the output side. So let's move this slightly down. Let's connect the panels in the second component, which is tangent. In our last video, we have seen about direction, how to see the direction, everything. This is showing the direction of the curve in the particular points. For your understanding, let's connect that to BD. As you can see, this is the direction of the curve in this particular point. This is this direction. When I was making script for this video, I had one doubt. Like these points and the tangent looks the same. There are 3 numbers in this also 3 numbers. Then how this will give the direction? Then I come to know the grasshopper uses unit vector, meaning if you are moving in the x direction, it will show direction as 1, 0, 0, meaning you are moving in the x direction. If you are moving in the y direction, 0, 1, 0. If you are moving in the z direction, 0, 0, 1. This is clear to me, but I don't see any 1 in this panel. So let's take the point 0.48, 0.87 and 0. Then what is this point means? Let me explain. Let's draw a circle of 1 meter from the 0 point. This is x direction, this is y direction. In the x direction, let's divide the 0 to 1 into 10 parts. 0.1, 0.2, 0.3, 0.4. It's continuous. Same way we will divide in the y direction. Let's say you are moving somewhere like this. Then find out this direction. Let's bring that to x and y. Now you can see this point. So this is the direction. This is not moving in the x or y. It's moving in between x and y, in the quadrant of x and y. Whenever you look at this point, whichever is higher, the direction is closer to that direction. As you can see, the y axis number is 0.8. So it is far away from the x axis and closer to the y axis. So this is how the direction is defined in the grasshopper. Let's move on to the next parameter. This is also we have seen in the last video. Let's connect the panel and see what are the outputs. To make the parameters as LCS, local coordinate system, let's reparameterize the curve. Now we got all the points in the LCS. Let's see one interesting thing. Let's divide this curve into 4 segments. As you can see at the parameter, start point 0. The next point should be 0.25, right? And midpoint should be 0.5, right? Why it's not showing like this? The parameter value is not based on the length. It's based on curve's mathematical domain. Let's understand parameter with a small analogy. Let's say you are traveling from your home to office. It takes almost 30 minutes. Then can I assume in 15 minutes you will reach the midway to your office? I cannot, right? Because there is traffic in the road. Somewhere you can find highway, so you can fast and slow accordingly. So it is always doesn't necessary you will reach in 15 minutes midway to your office. Same way, the parameter is like a time. How your time to go to your office affected by the traffic. Same way, the domain values affected by control points and its weights. So it doesn't always necessary the 0.5 means midpoint of the curve. We understand all 3 outputs. Whichever component we are going to see next also, all have the same outputs. So if it is clear, let's move on to the next component. So we will use divide curve. When you have a facade, you want to divide into particular segments. Let's say 6 segments or 4 segments. Then you directly take the divide curve and divide and fix the panels and finish the facade. Let's say your facade panel has particular size only. Let's say 1200 mm or 1500 mm. In that, the panel size is fixed. So you can arrange in that particular manner only. You cannot cut it or something. So in that time, we have to use divide length. Let's copy this curve. Let's move here. Divide length. Let's add the curve. Set one curve. Connect. Now you need the length. Usually you will know your facade length. You already have. In such situation, we can use curve length. Just connect this to the panel. It is 114 mm. Okay, let us have 20 mm panel. Let's connect. So 20, 20, 20, 20, 20, balance whatever it is. It will not divide the full curve. Whatever it is, that's a balance. As you can see, it is going nearby as you increase the distance. So we have 36, 36, 36, then whatever it is balanced. So when your panel size is fixed, you will use divide length. Also, one more interesting thing I wanted to say, since we are in this topic, let's look at the evaluate length. With this component, you can be able to put the point with exact distance what you require. Let's connect this curve. Let's copy this curve. Let's connect this. Now, there are two ways to put the point on this curve. So before we look at length, let's look at normalized. This is also Boolean value. There is, let's bring the Boolean toggle. What it exactly do? So with this component, you can position a point on the curve in two different ways. One is based on length. Otherwise, if you don't know the length, based on the percentage. Let's say you want to position a point around 35% of overall curve length. Let's look at it. If this is false, it will take the length as 0 to 1. The default value for the normalized is true. When you have the true here, it will help you put the point based on the percentage. If you want to position a point with 35% of the overall curve length, let's connect that. This is 35%. This is midpoint. This is 75%. The other way is this is false, which means you can input the length. Let's say 100. This is 100. You can move. You can position a point with the exact length. For that, you have to set as a false. Hope this is clear. As you can see, these all give the same outputs: points, tangent, and parameter. Let's connect 0.5. This is midpoint. Let's look at the parameter value. It is 52, not 50. As I said, it's a NURBS curve mathematical domain. So that's all right. Either you want to equally divide or divide by length. What else is there? There is one component called divide distance. Distance. This is also distance, right? No, this is length. This is distance. What's the difference? Let's say you want to put the street lights along with the curved road. You cannot equally divide and put the light. When the light is switched on, it covers particular area only. It doesn't care about the length, whatever you push. In those conditions, or if you are placing the tree better shading, then you have to position those based on divide distance. Let's copy this curve. Let's add the curve into Grasshopper. Now distance. How much distance? Let's put 20 only. It also does the same as curve length, right? But as you can see, these lengths are not equal. Okay, let me prove it to you. Before that, how it is taking the distance? Let's make this. So all the points came here. Let's draw a circle in this point. How much? 18 we have done. Here 18. So I put the 18 radius circle. As you can see, exactly it cut at that point. Let's put another circle from here. 18. Next point. Let's draw another circle. 18. So as you can see, it places the point with the distance. So it will not divide based on the curve length. It will divide as per your distance. To prove it to you, let's add this to divide length also. So same curve, same distance, but different outputs. These are based on length. These are based on distance. Hope this is clear. So when you place the street light, you will place it here. It will cover this much area conceptually, and next you will place it here, so you will cover it this much area. Then place it next to next points, like that. Okay, I got all the components. Divide curve, divide length, divide distance. That's all, right? Yes, that's all. In case if you want to break the curve in the particular points, let's remove the curves for a moment and remove this also. You have this much points, you have curve, but you have a single curve. You want this to break, you want this curve to break into multiple curves, 1, 2, 3, how much ever segments we have. Then you will use shatter. For that, you have to connect the curve, connect the parameter. The segment work based on the parameter, not based on the points. Be clear about it. Otherwise, it will be in the red. Parameter, then it shatter. You don't see any difference, right? Let's make this. There are two curves. I will remove the longer curve. Segment 1, segment 2, segment 3. As you can see, it shattered the curves. Let's summarize what you have learned in this video. So first we have used divide curve, which is the basic. Whenever you want particular segments, we will use divide curve. In that, we see about kinks. When your curve have edges, it will be helpful. Otherwise, we don't need to worry about the kinks. Next, divide length. When we have a fixed length of panels, we use divide length. Also, we see about checking the curve length or placing a point on the curve with the distance or with particular percentage. Then we have seen divide distance and the difference between divide distance and divide length. Then finally, we have seen shatter to break the curve into multiple curves. Hope everyone learned something new today. See you in the next video. Thank you. Bye bye.